Dear students, today we shall study the 10th standard geometry chapter triangles. Students, you are already familiar with the different types of triangles, definition of the triangles, and the congruency of the triangles. These are all you have studied in the previous 8th and 9th standard. You have familiar with the congruency of the triangles depending upon the axioms. First one is S axiom, S axiom, S axiom. Third one is A axiom. Fourth one is RHS axiom. So depending upon these axioms, we are going to show that the congruency of triangles. Congruency of triangles. Congruency of the triangles. Yes, axiom means side axiom. So I will just give the definition of the axioms, these axioms. So because you have already studied this, so it will these axioms will help you in the proof of the theorem, proving the theorems on triangles. So first one is a side axiom. So it states that in two triangles, if three sides of one triangle are equal to the corresponding three sides of another triangle, then they are said to be congruent. Students, understand this SSS axiom. If three sides of one triangle are equal to the corresponding three sides of another triangle, then the two triangles are said to be congruent. So if you take SAS axiom means side angle side axiom. So it states that in a triangle, if two sides, here side, if two sides and an included angle of one triangle, two sides and an included angle of one triangle are equal to the corresponding two sides and an included angle of another triangle, then those two triangles are congruent on the basis of SAS axiom. So coming to the third axiom, ASA axiom. So this ASA axiom means angle side angle axiom. So according to that axiom statement, it states that the two angles and a side of one triangle, two angles and a side of one triangle are equal to the corresponding angles on a corresponding side of another triangle, then those two triangles are said to be congruent. So, and the last one is RHS, right angle hypotenuse side axiom. Right angle hypotenuse side axiom. So here this axiom we are going to apply only for the right angle triangles. According to that axiom, it states that in a right angle triangle, the hypotenuse and the corresponding side of one right angle triangle is equal to another right angle triangle of hypotenuse and a side are equal. So then those two right angle triangles are congruent. So you have studied in the previous class. So these will help to prove the theorems. Okay, students. Now, students, you will see the similar figures. Similar figures. Students, if you observe the figures of first group of figure, so we see these two are these rectangles. So this is ABCD is a rectangle. So PQRS is also a rectangle. Students, can you identify the difference between these two rectangles? Yes. So even though these two are the rectangles, they have the same property, but here the shape is same. The shape of these two rectangles are same, but their sizes are different. Their sizes are different. So this is smaller than this rectangle. So observe the first figures. So these two are the rectangle. They are the plane figures. Both are the rectangles, but they are different in their size, but the shape will be the same. If you observe the second figures, so in these figures, these two are the triangles. These two are the triangles. So if you observe the triangles, so they are marked here. Here the first one is the ABC is a triangle. Second one is the DEF is a triangle. So in this triangle, side AB is equal to side DE, side BC is equal to side EF, so and side AC is equal to BF. Therefore, here these two triangles are having the same shape and same size. These two triangles are of the same shape and the same size. So therefore we can say that similar figures means the figures which have the same shape and the same size, or similar figures having the same shape, but not necessarily they are of the same size. Similar figures, we can define the similar figures. The two figures are said to be similar if they have the same shape. So here, observe clearly, this is a rectangle, this is also a rectangle. So both are same, both are same shape, but they are not equal in their size. So here, the two triangles are, the shape is triangle and also size is also equal. So if you observe this rectangle ABCD with the triangle ABC, so can you call these two as a similar figures? No, students, because this shape is rectangular shape, this is a triangular shape. So therefore, we cannot call these two as a similar figures. Students, understand that definition of the similar figure. Similar figure means, so the figures having the same shape, but in the compared to the size, they may be equal or may not be equal. Only the condition is they have the same shape. So if you observe these under under one example, so observe this. So this is an exercise. This is an exercise of the rectangular shape. This is an exercise. And observe this book textbook. If you observe this textbook, so observe, is there any difference between these two books? So this is also in the rectangular shape. This is also in the rectangular shape, but their size, observe clearly, their size is different. Textbook is larger than the top of the exercise. I think you have cleared about the similar figures. So these two are similar figures, but they are not equal in their size. Therefore, similar figure means the figures having the same shape. This is also rectangle, this is also rectangle. So they are differ in their size. So therefore, we can see some points on these similar figures. If two figures are said to be congruent, if they have the same shape and the same size. So when they are having the same shape and same size, they are congruent. They are congruent. So here, if you observe the figures 1 and 2, in the second figure, we can say that, or we can write that these two triangles are congruent. So, triangle ABC is congruent to triangle DEF. Triangle ABC is congruent to triangle DEF. According to the definition, they have the same shape and the same size. So, shape is here, it is triangle, it is also triangle. Whereas in case of, and the side AB is equal to DE, side BC is equal to EF, and side AC equals DF. So therefore, shapes are same and the sizes are also same. Therefore, these two triangles or these two figures are congruent. So coming to the second one, the two figures are in the same shape. If they have the same shape, not necessarily the same size, are called as similar figures. So this point, two figures having the same shape, not necessarily the same size, are called as only similar figures. only similar figures. So for this, we can compare this. They have the same shape, but are not same size. So you can in your home you have observed the different size of the photos of your family photos. So you can give the example also for that. Then coming to the third point, all congruent figures are similar. All congruent figures are similar, but similar figures are need not to be congruent. So if the two figures are congruent, then they are always similar. They are always similar. But similar figures are need not to be congruent. So for this point, observe these first figures. So these are the similar figures, but they are not congruent figures because their sizes are different. Their sizes are different. These two are the similar figures, but not congruent figures because these two are the same shape but differ in their size. Whereas in coming to this second figure, these two are congruent figures because they have the same shape and same length or same size. Okay students, I think you have cleared about the similar figures. Now students, we will apply this similarity for the polygons. Polygons you have already studied in the ninth standard. A plane figure which contains three or more than three sides are called as polygons. So observe the definition: two polygons of the same number of sides. So that means the polygon must have the same number of sides. So if it contains three sides, it is called as a triangle. If it contains four sides, it is called as quadrilateral. So if a polygon has five sides, it is called as pentagon. So on. So two polygons of the same number of sides are similar. Similar. So if you want to say, there are two polygons having the same number of sides are similar, the condition first one is their corresponding angles are equal. Their corresponding angles must be equal. Second condition is their corresponding sides are in the same ratio. Their sides must be in the same ratio. Ratio means they are in the same proportion. So this is the condition for the similarity of the two polygons. Observe clearly, two polygons of the same number of sides are similar if first one is their corresponding angles are equal and their corresponding sides are in the same ratio or in the same proportion. So if you observe the figure here, so here it is a polygon having a four sides, therefore it is called as a quadrilateral. So now observe this plane figure. A, B, C, D is a quadrilateral and P, Q, R, S is also a quadrilateral. Apply the first condition. So in figure, quadrilateral, ABCD and a quadrilateral PQRS. First condition is their corresponding angles are equal. So look here, angle A in the quadrilateral ABCD, angle A equals in the quadrilateral PQRS angle P. Angle A equals angle P. They are not 5 degree. Not 5 degree. Similarly, observe the angle B. Angle B equals here angle B. Measurement of the angle B is 100 degree. In this quadrilateral, angle Q is 100 degree. Therefore, angle B equals angle Q equals 100 degree. So next angle is C. Third angle is C. Angle C is 70 degree. Angle C equals angle R. Angle C equals angle R equals 70 degree. So angle D is 85 degree, as in case of this quadrilateral, angle S is 85 degree. 85 degree. So this first condition is holds good for this polygon, that is quadrilateral. The corresponding angles are equal. Angle A is corresponding to angle P, 105 degree. Angle B is corresponding to angle Q, is 100 degree. Angle C is corresponding to angle R, which is equal to 70 degree. Angle D equals angle S, which is equal to 85 degree. So now we will check the another condition. Another second condition is their corresponding sides are in the same ratio. So if we take their ratios of the corresponding sides. So now we will take PS ratio corresponding sides ratio. Sides ratio. Here we have written the angles, corresponding angles. So PS by AB. PS by AB. So the length of side PS is 4.25. The length of AD is 2.1 centimeter. Here centimeter get cancelled. So 2.1s are 2.2. 2.1s are so 2.1 into 2 you will get 4.2. So it is 2. So therefore the ratio of PS by AD is 2. Now we will take the ratio of PQ by AB. The ratio of PQ by AB, which will be equals, it is 3.0 or 3 centimeter by 1.5 centimeter. So centimeter cancels. 1.5 ones are 1.5 are 3. So here also we obtain the ratio of PQ by AB is 2. Similarly, if we take, so on the side, QR by BC, QR by BC, QR by BC equals 5.0, that is 5 centimeter by BC is 2.5 centimeter. So if you get 2.5 means are 2. So again here also the ratio is 2. And the last one is RS by CD. RS by CD equals 4.8 centimeter by 2.4 centimeter. 2.1s are 2.2s are. So here also ratio is 2. Or you can write AD by PS, you will get 1 by 2. So this will be AB by PQ, we will get 1 by 2. So then also, if you write AD by PS, it will be 2 by 2.1 by 4.2, it will become 1 by 2. So therefore, you can write that for these all the ratios are equal. So therefore, you can say that the two polygons are similar. Two polygons are similar. Okay, students, you have understand the definition of the similarity. So first condition must be so corresponding angles of two polygons, similar polygons or corresponding angles must be equal, and ratio of their corresponding sides must be the same. Now students, we will see the similar triangles. We have studied the similar polygons. Now similarity of the triangles. See the similarity of the polygons. Now particularly we will come into the similarity of the triangles. So by the definition, two triangles are similar. So you can say if the two triangles are similar, so these two conditions should be holds good. So first condition is their corresponding angles must be equal. So and the second condition is their corresponding sides are in the same ratio. Corresponding sides must be in the same ratio. So what we have learned in the similarity of polygon. So but here we are going to apply it for the triangles. So therefore it is we have taken the same corresponding angles must be equal. So their corresponding sides must be in the same ratio for triangles. Then we can say that those two triangles are similar. So another point here we have to remember. So that point is if the corresponding angles of two triangles are equal, that means in a triangle, if all the three angles of one triangle are equal to all the angles of the other triangle, so then those two triangles are called as equiangular triangle. So they are called as equiangular triangle. The word itself says that equiangular. Equiangular, that means the angles of one triangle must be equal to the corresponding angles of another triangle. So we call equiangular triangle as an equilateral triangle also. So next, coming to this point, the ratio of any two corresponding sides. Ratio of any two corresponding sides in two equiangular triangle is always the same. In equiangular triangle, if we take the ratio of the corresponding sides, they must be equal. They must be same. So this result is this result is used by a famous Greek mathematician. Famous Greek mathematician. Greek mathematician. Thales. theorem. Shortly we call as EPT. Shortly we call that theorem as a EPT or Thales theorem. Thales theorem. The result of this statement is used by the great mathematician Thales. So, in basic proportionality theorem proving in that theorem, so or it is also called as a Thales theorem. You are going to prove this theorem in this chapter. Okay, students, we will see. So some the theorem in the next way. Students, observe the photo of the tails. So observe here, this is the photo of the great mathematician Thales of Greece. So here is a little information about the Thales. So observe carefully. So he is lived in between 624 to 546 BC, so in Greece. So he was the first known philosopher and mathematician. He is credited with the first use of deductive reasoning in geometry. He discovered many propositions in geometry. He is believed to have found the heights of the pyramids in Egypt using the shadows and the principle of similar triangles. So we will prove his theorem now, students. Now, students, we will see the proof of the Thales theorem. First, we will see the statement of the theorem. In the previous class and also in the previous year, you are studied how to prove the theorem and what are the steps followed in proving the theorem. So a theorem contains the statement of the theorem contains two parts. So first part is the data are given and the second part is the conclusion. So by using the data, we are going to prove the conclusion. So after that, the steps which are followed in proving the theorems, we call it. So first one is the drawing the rough sketch for that statement. Second one is we have to write the data, second step. Third step is what we have to prove by using that statement. So third one is the to prove. Next step is if it is necessary, we are going to make construction or rearrangement in the diagram. So, and the last step is proof. Now, students, we will see the statement of the Thales theorem. So, this theorem is very important for the examination purpose also. So, you will get 5 marks or 4 marks. So therefore, this you have to study well in your home by practicing it. So now the statement it states that if a line is drawn parallel to one side of a triangle, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points. The other two sides are divided in the same ratio. First, we have to understand the statement. here a line is drawn parallel to one side of a triangle. So that line drawn, it intersects the other two sides. Intersects the other two sides in the distinct points. That means in different points, such that the other two sides are divided in the same ratio. So by observing this statement, we have to first draw the triangle. Here, a triangle is drawn here. ABC is a triangle which is drawn here. So here I have drawn a parallel line to BC. So that is DE. DE is a line segment which is drawn parallel to BC. So not only for BC, you can draw the parallel lines. You can draw parallel lines for parallel line for AC also. So here also you can draw the parallel line, or you can draw the parallel line for the AB. So that is by joining these two points. So here I have taken in a triangle ABC. So D is a line segment drawn parallel to BC. So this parallel line intersects the other two sides. Other two sides of the triangle are AB and AC. So in this figure, we have drawn DE parallel line to BC. So if you left this side, the other two sides are AB and BAC. So this line segment DE intersects these two lines at different points D and E. So now we will write the data. So this is a given triangle. So the data is in triangle ABC. DE is a line drawn parallel to BC. So these arrow mark indicates that they are parallel lines. So you are already familiar with the word parallel lines. Parallel lines means if lines which can be extended on either side. The two lines extend on the other two sides. If they will not meet at any point. So such type of line segments are called as parallel lines. So in a data is in a triangle ABC, DE is parallel. This symbol indicates parallel lines. DE is parallel to BC. So then, students, the next step is to prove. So by seeing this statement, so this line segment intersects the other two sides. So these points, that means D and E, divides these line segments in the same ratio. That means the length of AD is AD by DB is equal to the length of AE by EC. So that we have to write in the proof. So therefore, to prove it is AD by DB equals AE by EC. AD by DB equals AE by EC. This we are going to prove in the theorem. So for this, so we cannot prove this theorem directly. For that, we are going to make some correction. That means the construction. So now, what will the construction is that join BE and C. Join BE and C. So I am going to join these B, the points B and E. This will be drawn by the dotted lines. Dotted lines indicates that they are not in the given figure, but they are drawn at the time of the construction. So B is join. Similarly, join CD. Join CD. So similarly, as in the previous line segment, so this is joined by drawing a dotted lines. Next, then draw DM perpendicular to AC. So for this line segment AC, we have to draw DM perpendicular line should be drawn. Perpendicular line should be drawn to the AC. Call this as DM. And EN perpendicular to AB. So by joining this vertex E, you have to draw perpendicular of the line AB. Here the perpendicular is drawn to the line segment of the side AB. So this is called this as EN. So this is the construction. Now, next step is proof. In the next step, students, we are going to compare the two triangles. These two triangles are triangle ADE and triangle BDE. Triangle, here it is triangle ADE. Compare this triangle ADE with triangle BDE. So this triangle BDE. So this triangle with ADE. So now we will write the area of the triangle, both the triangles. So area of the triangle ADE to the area of the triangle BDE. So we are going to compare these two triangles ADE and BDE. So we are taking the area of those two, the ratio of the area of those two triangles. Area of triangle ADE to the area of triangle BDE. So you already know that. So what is the formula to find out the area of the triangle? Yes. So this half into base into height. So now for the triangle ADE, observe clearly for the triangle ADE. So half into, so the base is AD, half into AD into, this is the height, AD into EN. Therefore, the area of a triangle ADE was half into AD into EN. Similarly, for the triangle BDE, so it is half into base into height. So half into, here the base is BD. So where so height is EN. Height is EN. So here, if you observe, so the numerator and the denominator of the right side, so half get cancels. So EN and EN get cancels. So in the right side, the remaining thing is AD by DB. So therefore, after the simplification of this, we will get area of triangle ADE to be area of triangle BD equals AD by DB. AD by DB for this as equation number 1. So next we will compare another two triangles. So this AD with CD, the same triangle AD. We are going to compare now the same triangle ADE with the triangle CDE. With the triangle CDE. So we are going to compare this and this triangle. So here also we are going to write the areas of those two triangles. So here the area of triangle ADE to the area of triangle CDE equals. So again for this triangle ADE, so this triangle ADE, if we take AE as the base, in the previous case we have taken AD as the base, here we have taken AE as the base, therefore it will be half into AE into DM. So this will be half into AE into DM. Now we will write the area of triangle CDE. So area of triangle CDE equals again half into base. Base is EC and the height is DM. Height is DM. So if you simplify the right side, half will cancel. DM is common. So it will also get cancels. The remaining is AE by EC. Therefore, the area of triangle ADE to the area of triangle CDE equals AE by EC. All this as equation number 2. But students, so in the figure, the area of triangle BDE equals DEC. The area of triangle BDE equals area of triangle DEC. So observe here, area of triangle BDE. So BDE, this is area of triangle BDE is equal to the area of triangle DEC. Observe clearly, DEC. These two triangles. So all if you call 1 and 2. So these two triangles are equal in their area. Why they are equal in their area? So because to recall the 9th standard triangle chapters, these two triangles are standing on the same base DE. These two triangles are standing on the same base DE and between the same parallel lines and between the same parallel lines DE and BC. Therefore, the triangles standing on the same base and between the same parallel lines are equal in their area. Therefore, all this as an equation number 3. So from 1, 2 and 3, from equation number 1, 2 and 3, we will write the ratio of AD by DB equals DE by EC. So I think students have understand how to prove the theorem. Hence this is an important theorem for the examination purpose of how to be perfect in this theorem by practicing it. So more times we have to work it. So by understanding the statement, write down the diagram. So after seeing the diagram and the statement, write down the data. So in the statement itself, they have given the data and the what we have to prove or what we have to come to conclusion. So that conclusion is the to prove. So to prove the theorem, if we want to make a constructions or alternation in the given figure, that is the construction. So So the next thing is our last step is proof. That proof, so simply we are just comparing the areas of the two triangles. So after that simplify, we will get the proof. Okay.